Right. In this regression model, simple regression model, last week we constructed 420 equals 6a plus 24b 1770 24a plus 106b. Right. Simultaneous equation you can solve by using equation mod in the calculator. Right. Manually, if we want to solve A or B, you want to remove, you know, right? First I solve manually. Okay. This is my simultaneous equation 1, simultaneous equation 2. If you are going to remove A, common denominator is 6, 24, least common multiple 24. Then first equation, if you multiply by 4, 6a can be taken into 24a, then you can remove, you know. Right, now I multiply entire equation 0, 8, 1680. 24a plus 16, 8, 9, 96 b, third equation. Then 1770 equal 24a plus 106b, my second equation. Then I can subtract, then simultaneous equation will become simple equation. From the third one, I subtract second one, then 1680 subtract 1770 equal 24a subtract 24a plus 196b subtract 106b. That's it. And then 0, 8, 9, 17 minus 19. 24a, 24a is set off 0, 96, then 0, 9, 10, minus 10b. Minus 90 equals minus 10b. b means minus 90 divided by minus 10. You have done all these. B9. You have done before O level, you have done all this. Right, simultaneous equation. Right, B value I substitute one of these equations, then B equals 9 is substituted. One of these equation, I take one, substituted 1. Substituted in equation 1, 420 equals 6a plus 24b. I substitute. B equals 9. 420 equals 6a plus 24 multiplied by 9. 420, 6a plus 36, 3 left, 18 to 16. Then 420 minus 216 equals 6a. 410, 20, 204, 6a. A means 204 divided by 6. That's my A. 3, 18, 1, 2 left, 34. Just obtain that value. A equals 34, B equals 9. Now obtain the values for model. Your regression model y equals a plus bx. Then you can write your final model y equals a34, b means 9x. 9x. In wording, if you want to write, right, promotion expenditure and sales. Promotion expenditure and sales. Right, then you can write the equation if you want. Y means promotion expenditure, promotion sales income dependent, sales equals 34 plus 9 promotion expenditure. This is your that is the bottom. To the question number 1, we did this. Sales, promotion, expenditure. Sales 34 plus 9 promotion expenditure. Okay? Isn't it? Compute the coefficient of correlation and identify the association between promotion expenditure and sales income. How we interpret this? When the promotion expenditure is 0, all this in thousands, sales income will be 34. That is 34,000. Promotion expenditure has positive effect on sales income. 1 unit change of promotion expenditure has a positive effect on sales income to be changed by 9 units. That is the idea of this. This is the best line of best. Right. Now we interpret the results like this. In the regression model, constant is 34. Constant is 34. This means that when the promotion expenditure is 0, when the promotion expenditure is 0, sales income will be come on. Sales income will be 34,000. What is the message? I don't know. No, that's okay. Mike. Somewhat. Right. Sales income will be 34,000, right? 34,000. No, 34 in thousands. Right. This is 9, right? Now we write beta value of promotion expenditure. Beta value of promotion expenditure is 9. Beta value of promotion expenditure is 9. This one. This says that when the promotion expenditure is changed by 1 unit, is changed by 1 unit. When the promotion expenditure is changed by 1 unit, sales income will be changed by 9 units, positively. Right. Therefore, you can use this model to forecast. Right. Now write this one. Forecast the sales income. If the promotion expenditure is, right here, this is 1000, right? Promotion expenditure is 10,000 rupees. Promotion expenditure is 10,000 rupees. 10,000. Right, model has been constructed to thousands. Right? Therefore, 3 zeros you have to cut when you substitute in the model. Right. Now substitute in the model and identify the sales income forecast. Right, I can forecast my sales income, that is Y 34 plus 9 multiplied by advertisement expenditure or promotion expenditure 10. Now simplify. Y equals 34 plus 9 into 10, 90, 4, 9, 12, 124. Or in 1000 if you want, 124,000. This is correct because we know in thousands, 124,000. Right, if there is a model, you can use that model to forecast. In the forecasting, you use that model. Right, now, without using these steps, because these beta values may be decimal points, also they are maybe. Therefore, substitute this simultaneous equation in your calculator to obtain the values, because we are not expecting the steps of simultaneous equation solution. That is very basic thing. We have done. Right, solve these simultaneous equation using your calculator. In your calculator, fx 100 ms or 991 ms, you are having equation mod. ES calculator I will show. MS calculators, right? Press your mod key. When you press 1 or 2 times, you can see equation mod. EQN 1 or 2 or 3, right? 1. Right, when you see equation, press 1. Then you are coming to equation mod. Okay. Then your option it will be unknown. By default, unknown. That is simultaneous equation. In the same calculator, you can see degree also. The same option, degree. To see degree, when you press this button, right and left, you can see unknown to degree, degree to unknown. Isn't it? Right. 2 and 3. Here also 2 and 3. But we need unknown option. This option. This is simultaneous equations. Simultaneous equations. Right? Simultaneous equations. Degree means quadratic equation, cubic equation. Quadratic and cubic. वर्ग सम गणज समीकरण. Quadratic cubic. These simultaneous sequences samagami samikara. Two equations being unknown, press number 2, then you are coming to simultaneous equation 2. Right, then calculator asks what is A1, isn't it? A1 means this is your A column, B column, C column. Calculator asks what is the value of this coefficient U type 6 equals 9. Only that you have. Calculator asks B1, that is 24 equals 9. Then it asks C1 420 equal. Then it goes to second equation. A2 is what? 24 equal. B2 106. Then C2 1770 equal. Right, you have entered. Then press equal sign. Calculator gives X value. X means my A value 34. Again press equal sign. Calculator provides Y value. Y value means my B value. That is 9. Right? Very quickly you can solve. No need to waste time. Solve it simultaneously manually, step by step. That is not expected from you because you are advanced. So simultaneous equation solution is very basic thing. Right. ES calculators do you have? Right. I think you are not having problem. You know, no? Right. If it is, okay. Yes, calculators, should I explain? Okay, no. Right. Okay, then your model you have written y equals 34 plus 9x. I think that you are aware of these your calculators. They are all no problem. Right, my model is y equals 34 plus 9x. I cleared all to take this case. Right, when you are using this model,
excuse me, sir.
The model is like this: y equals 34 plus 9x. You cannot decide whether this model is appropriate to take the decision. Right?
Excuse me, sir.
Whether the model, yes.
Sir, when you are writing on the left side of the corner of the whiteboard, we can't see properly, sir, because of the angle of the camera.
That is a very left side.
Yeah, sir. Because it's a very angle way the camera is.
Is it what is the point that you can explain? Is it okay from here to the right side?
Now the focus is gone, sir, from the camera. Focus is lost. Camera focus gone.
Can you focus it? Is it okay for you?
Now seems to be okay, sir.
All right. Okay.
Thank you, sir.
Right, y equals 34 plus 9x, this is your model. Then when you test your model in your business, in your organization, in your research, you want to test whether this model is appropriate, whether that model is good, you want to test. For that purpose, we want to test regression ANOVA result, regression analysis of variance. From that you can decide whether my model is appropriate. That's the way you decide, right? But in diploma level like that, from this you can finish. But here in degree level, you want to go another step as well, right? Right. Then we want to write down subheading regression ANOVA, regression ANOVA. Regression ANOVA. ANOVA means analysis of variance. Analysis of variance. Analysis of variance. Regression ANOVA. There is another ANOVA, one-way ANOVA. After this we start. This is regression ANOVA. You can justify in your research whether my model is appropriate or not by using regression ANOVA. If regression ANOVA result is insignificant, you have to forget about that model. You have to take more data, you have to increase your variables like that. Regression ANOVA should be significant, appropriate, then you can use that model to forecast. Otherwise, model is invalid. Okay? Right. Briefly write down the meaning step by step. We do that. Using regression ANOVA, using regression ANOVA, using regression ANOVA, we can decide whether the regression model is appropriate or inappropriate, appropriate or not appropriate. This means that validity of the regression model, validity of the regression model is tested by regression ANOVA result. If the regression ANOVA result, is insignificant, within bracket, not appropriate. Right, not appropriate, invalid, different terms, right? If the regression ANOVA result is insignificant, we can't use that model. Using following steps, regression ANOVA result can be tested. Right, our model y equals 34 plus 9x. Now I am going to test that. Right, step one. Define null hypothesis. H naught, we write model is jointly insignificant. Insignificant means not appropriate. Otherwise, invalid. Not suitable. That is step one. Therefore, you can write model is invalid. That is enough. Step two. Define alternative hypothesis. Alternative hypothesis HA model is jointly significant. Significant means that is appropriate model. You can use that model. That is valid model. So that is a validity test. Valid test. Then step three. Decide the level of confidence so significance. Decide the level of confidence or significance and identify acceptance and rejection regions. using F distribution. Using F distribution. F distribution. F table. F distribution. This is the right skewed distribution. This is the right skewed distribution. Right skewed distribution. This is the right skewed distribution. දකුණට කුටික වෙච්ච ව්‍යාප්තියක්. Right skewed distribution. Like this. It is having only positive side, no negative. But T table, Z table, there is left and right, both positive, negative. But this is having only positive side. Right, only one sentence write down. It has only positive side. It has only positive side. Right, like this, right is skewed. Right is skewed. Right. Then I take 0.05 significance rejection region. 0.95 confidence acceptance region. This is initial point 0. This is F critical value. Critical value. F critical value. F critical value. From the table you take F critical value means that is F table value. Table value. How you obtain this F critical value? F tables there, I clearly understand, 5% significance there, 0.05. That is that table. Alpha 0.05 table. This is rejection region is provided significance. Other table there alpha 0.01, 99% confidence table there. Another table there alpha 0.10, 10% means 90% confidence table there. But frequently we use 5%. Therefore that table is given. Right? No need to use this one. When you take this table, see degrees of freedom here, numerator. Then this vertical axis, degrees of freedom, denominator. In the surface or body of the table, you can see F critical values. Critical values. Same table. This degrees of freedom, when we use the formula with denominator, numerator, that is following F distribution, we want to use denominator, numerator, degrees of freedom. Because there are some formulae, we want to use denominator, numerator. Then we use same table. Regression models we use, numerator means this is regression. Degrees of freedom, regression. Degrees of freedom, residuals. We want to use in regression models. When we use one-way ANOVA, our next topic, that is also following F table, F distribution, degrees of freedom between groups between groups. Degrees of freedom within groups. Within groups. Understand same table. Same table. Therefore, this horizontal axis, numerator regression between groups, vertical axis, denominator residuals within groups, all these are same. But when we are using formula with denominator numerator, you use degrees of freedom, denominator numerator. In the regression model, degrees of freedom, residual, regression. One-way ANOVA, degrees of freedom within groups, between groups, but same critical values. Clear? Right. Then here we want to use to identify this F critical value, degrees of freedom, residuals, and regression. It represents denominator, numerator. In this table, you can see denominator means degrees of freedom residual, numerator means degrees of freedom regression. Okay? Clear? I asked that whether you understood. Right, understood. Because when you are using some formula, numerator and denominator. One-way ANOVA within groups, between groups, but same table. When you look at again F distribution indicating here residual regression, don't think that that is another table, same table, but only terms. Denominator means regression, numerator means denominator means residual, numerator means regression. Same table. Right, using that residuals and regression, degrees of freedom, these points should be identified. Okay, right. In the same step, slide down, slide down. Using degrees of freedom, residuals, and degrees of freedom, regression, and degrees of freedom, regression. F critical value can be identified. F critical value can be identified. Like one exercise, when we finish, you understand. But until that, step by step, you want to write down each and everything. This point from this table, if you think that here, suppose 10 degrees of freedom, here 4 degrees of freedom, then you take that point here. That's the way. At the moment, you do not know how to calculate degrees of freedom residual, degrees of freedom regression. In the next step, we do all these calculations. Step 4. Right. Now take step 4. Step 4. Calculate F test statistic. Calculate F. Here is calculate F test statistic. Calculate F test statistics. Using regression ANOVA table, F test statistic is calculated. using regression ANOVA table, F test statistic is calculated. Right. This is the regression ANOVA table. My objective to calculate F test statistic. Then regression ANOVA table is like that. After the heading, you can take only 3 lines. This heading, right? This is ANOVA table. When you check in the statistical package, also you can see the table. This is model SS, DF, MS, and F test statistics. That's the table. First line regression, second line residual, third line top. That's my table. These points you need to calculate. Only this. Statistical package also calculate these sets. But we want to understand step by step. At the moment, note down this one. This is degrees of freedom regression, degrees of freedom residual. When you identify these 2 points, then you can identify from the table critical value. Right? This is step 3 critical value you obtain after constructing regression ANOVA table. Right? That is step 4. Calculate F test statistic is step 4. SS means sum of square. Sum of square, SS. DF, degrees of freedom. You are familiar, degrees of freedom. MS, mean square. This is the objective F test statistic. F test statistics. F test statistics. Right. When you calculate this F statistic, finally you decide your conclusion. Last step. If test statistic belongs to acceptance region, H not accepted, model is not valid. If test statistic belongs to rejection region, H not is rejected, model is valid. That's the decision. Right. Then step 5 we write down conclusion. Conclusion. If F test statistic belongs to acceptance region, H naught is accepted. Model is invalid. That is not appropriate. Insignificant model. Don't use that model. If F test statistic belongs to rejection region, if F test statistic belongs to rejection region, H naught is rejected. H naught is rejected. Model is valid. Model is valid. Right? Joint a significant model. Right? When you are presenting, suppose that you are going to present international conference your research finding, then you use F test statistic insignificant. Then you interpret. Then the panel audience may question you. Your model is invalid, no? Then how you can interpret that? Therefore, that knowledge you should have. This should be significant. If it is okay, model is valid. Otherwise, if your statistic comes to acceptance region, model is invalid, then don't use that model to interpret the results. It is invalid model. Right, now this question, we want to follow these steps. This question. Okay, y equals 34 plus 9x. Right, with me you can start. Right, decide whether this model is appropriate or not. I take my data, promotion expenditure, all this data, but you are having this data. If you have spaces to the right side, in the same place you can calculate promotion expenditure, that is 6, sales, y. Or you can take separately 2, 3, 4, 5, 6. If you want, you can start again calculation. 50, 60, 60, 80, 90, 80. So separately start in another sheet or in the same place you can continue the calculation. Whatever you use in the correlation or regression analysis. Right. Keeping space to the right side, I write my null hypothesis, H naught. Model is invalid. My step I write. Model is this one. Y equals 34 plus 9x is invalid. Alternative, model is valid. Invalid means insignificant. Valid means significant. Right. Then acceptance and rejection region using F distribution. I take at the moment rejection region 5%, acceptance region 95% confidence, here 0. Later I take F critical value. Right, then I construct my regression ANOVA table. Model, this is my ANOVA. sum of square, degrees of freedom, mean square, F statistic. Regression, residual, total. Right, I want to calculate this point, but you don't mark. I mark here to explain. These points I want to calculate, right? But you keep blanks. These points I want to calculate. Then step by step, I calculate and delete these cells, put that value. Right, now I want to calculate this. Steps, if you take, these are the steps we noted down. Right, now I want to calculate this. First I start from sum of square. Sum of square we want to calculate. When you calculate, y is my original value. Original value. If I want, I can calculate y bar also. Sigma y divided by a. You know. If it is this model, that is a predicted one, forecasted one. The forecasted model we use y hat. Y hat. If we construct a model that is the predicted one, it is called y hat. Y hat. Otherwise, y cap. Y cap. Hat. Hat. Y hat. Predicted value y hat. Average value y bar. Original value y. According to that, you can calculate sum of square these values. Right. Then take subheading under step 4. Sum of square. Sum of square. Sum of square. वर्ग करला गන්න එකතුව. Sum of square. Okay, right. Then continue. Original y value is denoted by y. Denoted by y. Denoted by y. Forecasted value is denoted by y hat. Is denoted by y hat. Y hat. Otherwise y cap. This means that our predicted model is y hat equals 34 plus 9x. Y hat equals 34 plus 9x. Average y value is denoted by y bar. Y bar. You want y bar equals sigma y over a. You know in descriptive statistics we have done y bar. Using these figures, sum of square can be calculated. Sum of square can be calculated. Sum of square can be calculated. Step by step I want to explain, clearly understand. Sum of which square can be calculated. And here is to get space. Right. Now see, when I take a graphical presentation like that, x and y, understand clearly. And then later you can construct. Right. I construct my model. Y hat equals 34 plus 9x. Suppose that. Average value I calculate, average everywhere, that is same y bar. Then I take only one plot, original plot, y plot. Right? You one plot, but you know 1, 2, 3, 4, 5, 6 plots, but I use only one plot to explain. If I take this distance, perpendicular distance, what you can see, this is the area covered by the model, explained by the model. Because under the regression model, you can see that distance, explain area, explain. Out of this y plot, this area unexplained, not covered. Summation of these two is the total. When you take only y plot, some portion is covered by the model, some portion is uncovered by the model, both of these total. Right, this is the variance covered, this is the variance uncovered, this is the total variance. Here, when we take with regard to only one plot, sum of which square, I can write like this. Sum of square of total equals summation of these two. Sum of square regression plus sum of square residual. Sum of square residual. Right? Up to that, is it clear? Right. Then what can you see according to this? Now take regression, this part, covered. Regression means covered by the model. Residual means uncovered by the model. Therefore, explained variance is regression, unexplained variance residual. Those here, this is the total. Right? So then understand regression means covered area. Modeling explained by the model. Residual means unexplained variance. Unexplained. Then summation of these two, we say total variance. Total variance. Okay? Right. Then sum of square. Your topic is sum of square. Isn't it? Right. Then write down like this. First right? Now sum of square, write down. Right. Continue. Out of the total variance, some amount is explained by the regression model. Explained by the regression model. This is called sum of square of regression. Sum of square of regression. Some amount is not explained by the regression model. Some amount is not explained by the regression model. This is called sum of square of residual. Sum of square of residuals. Both explained and unexplained. Both explained and unexplained variance. Both explained and unexplained variance are taken as the total variance. Are taken as the total variance. Are taken as the total variance. Then we can write following equation. Sum of square of total equals sum of square of regression plus sum of square residual. Right. Now note down that graphical presentation using only one plot. At the moment, explain, unexplained, and total. Model එකෙන් cover වෙන ප්‍රමාණය, cover නොවන ප්‍රමාණය. Explain by the model, unexplained by the model. Then total. Right. Take this graph under this. Right. Some critical points I discussed, therefore clearly understand. Only one plot here, but remember many plots there. Right, this explain means this regression, then regression, REG, regression. Unexplained means residual. Unexplained means resid, RESID, residual. No explain, unexplained. Explain means regression. This is to explain. This is your unexplained. Unexplained. Summation of these two you can see as the total variance. Right, if it is what I want to calculate first, I calculate SST. Under SS, we want to calculate SST. Right, then take subheading under SS, SST. SST. This is the sum of square total variance. That is both explained and unexplained variance. Like we write down SST. This is the summation of total variance. This is the summation of total variance. Total variance. That comprises both explained and unexplained variance. Both explained and unexplained variance. Right. How I can calculate this? Now see, you understood both explained and unexplained. This gap with regard to one plot. Then I write SST like this. Understand clearly? Y minus Y bar, then this part you can subtract. Y minus Y bar is that gap. Isn't it? Okay? Original value subtract. In this slide you can see Y bar. Then you can take that plot. But if there is a plot under that, what would happen? Y minus Y bar, when we take negative value comes, isn't it? To remove negative, always we take square. That's why total Y minus Y bar is square to the power of 2. Do you have only one plot in a scatter diagram? This is scatter diagram. Many plots. To all the plots you have to apply same thing. Therefore, sum sigma. Therefore, SST means sigma Y minus Y bar square. Clear? That's the total variance. Very clear, isn't it? It is very clear for me. Sigma Y minus Y bar square. This is the formula for SST. Okay, right. Now write SST equals sigma Y minus Y bar square. From this you can understand better. Okay, then I want to calculate. Y there. I want to take Y bar. Y bar sigma Y over N. Sigma Y means summation of this you have done. 0, 8, 9, 17, 20, 25, 30, 36, 42. 420. 420 divided by 6 observation means 70. Right. Y bar 70. Y bar 70. Y bar 70. Right. Now you can do this calculation. Y minus Y bar squared. Another column you take. Another column. Y50 Y bar 70 squared. 50, 70, no need to worry about negative. 20 squared, 400. 60 minus 70 squared, 10 squared, 100. 60 minus 70 squared, 10, 100. 80 minus 70 squared, again 10, 100. Like that you can. 90 minus 70 squared, 20 squared, 400. 80 minus 70, 10 means 100. Now take, that is sigma y minus y bar square. SST 4, 5, 6, 7, 8, 1001. SST 1200. Sum of square total 1200. It means that SST, this value 1200. 1200. The table. Okay. Right here, at the same time, I want to calculate the degrees of freedom of SST, that is given by n minus 1. Right. Again, write down. Degrees of freedom is given by df equals n minus 1. N minus 1. N means pairwise 6 observation minus 1, 5 degrees of freedom. Here should be 5. 5 degrees of freedom. Okay. Then we start this portion, that is SS regression. Right. Then take subheading SS regression. SS regression. Right. That is the explain variance. Right. Now we write. This is the variance. This is the variance explained by the regression model. Explained by the regression model. Explained by the regression model. That is, now you can calculate using this. SS regression means this part. In this line, always we can see y hat. Subtract y bar. To remove negative square. Many plots sigma. Therefore, sigma y hat minus y bar square. Y hat minus y bar square. Right, you are having y bar 70. Y hat you want to take. Y hat means my model. 34 plus 9x. When you substitute x values, you can take predicted values. Right, now I am going to calculate that. I write here to take this case. Now take y hat value. Y hat value. First, y hat value I want to take. Substitute 2 instead of x. 34 plus 9 into 2. 34 plus 9 into 2, 18. 8, 12, 3, 4, 5, 52 is my predicted value. Actual value 50, predicted value 52. That is the variance. Next point, 34 plus 9 into 3, 34 plus 9 into 3, 27, 11, 3, 5, 6, 61 is my predicted value. 60 is actual, 61 predicted from the model. Right, similarly calculate all these. Then 4 when you substitute, what is the answer? 34 plus 9 into 4. Using calculator you can do 34 plus 36, 70. Here also 4 means 7. Then 5. 34 plus 9 into 5, 34, 45, 9, 79. Then 6. 34 plus 9 into 6, 54. Then 8, 88. 88. Predicted values. Because model, if you construct a model, that is a predicted one. Predicted one. Forecast. Okay. Right. Then you can find these values. SS regression you can find. As I explained, I want to calculate this portion sigma y hat minus y by square. Now take another column. Y hat minus y by square. Y hat 52, y bar 70, that is square. 52, 18, 18 is square, 324, no, 320. Then 61 minus 70 square, that is 9, 9 square, 81. 70 minus 70 square, that is 0. Here also 0. 79 minus 70 square, 8, 9, 9, 81. 88 minus 70 square, 83, 24. Don't think that it should be balanced. No, no need to balance. Here 324, here also 324, 81, 81, but no need to balance. Right? Right, 3, 5, 8, 10, 3, 4, 0, 10, 810, no? 810. Sigma y hat minus y by square 810. Then you can see this point, sum of square equation 810. Our objective to calculate F statistics. Make a calculator. Right. Here degrees of freedom is given by K. Right. Degrees of freedom is given by df equals K. Degrees of freedom is given by K. df equals K. K means number of independent variables. Independent variables. Here simple regression model means one independent variable. Simple, only one. Right. Here K equals 1. Then write here 1. Number of independent variable, that is K. K is 1. K is 1. Case 1, number of independent variables. Okay. Then take SS residue. SS residue. Sum of the star residue. SS residue. Sum of the star residue. This is unexplained variance. This gap. Y minus Y hat. That's gap. Y minus Y hat. Isn't it? Right. Now write down. This is the unexplained variance. 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 Unexplained variance. This is the unexplained variance by the regression model. By the regression model. This is the unexplained variance by the regression model. That is Y original value, Y at predicted value, that gap. Only that. To remove negative value, square. Many plots? Sigma. That's the formula. Sigma Y minus Y hat square. Okay, let's calculate. Right, now I clear this stuff. Y minus Y hat square. Y 50, Y hat 52, square 2 square 4. 60 minus 61 square 1 square 1. 60 minus 70 square 10 square 100. 80 Y, sorry, yes, Y hat 70 square 100. 90 Y 79 predicted value 11 121. 80 actual value 88 predicted value square 64. Now take that summation, that is sigma Y minus Y hat square. 4 5 10 1 left 6 8 9 1 2 59. Then this is 390. Right. Summation of these two 0, 9, 10, 8, 9, 12, 1200. If you fill only two values, balance you can take. Cell dekha karo to you take that. Right. At the exam you can do like that. Right. When you are developing a model for your business, you can do that. But here you want to practice. That's why we calculate 390. Right, degrees of freedom, how we calculate? Right, now right, degrees of freedom is given by n minus k minus 1. N minus k minus 1. N6, one independent variable minus 1. Why this is 1? That is for the constant. 6, that is 4. If you take the balance also 4. Like 10:45 we take a break. No, before that I need 10:45. Because up to 12 today we have. Then if you have calculated these values, mean is very easily you can calculate, right? Then take mean square. Mean square. Mean square. Mean square indicates sum of square divided by degrees of freedom is called mean square. Very easily you can calculate MS equals SS over dm, degrees of freedom. Right, now we write down. When we divide sum of square, by degrees of freedom, mean square can be calculated. Right, that is MS equals SS over df. Right, now I calculate MS regression. I calculate 810 divided by 1, 810. This point 810. I calculate mean square acid 390 divided by 4. 936, 3 left, 30 means 7, then 220, 97.5. SS divided by degrees of freedom. Right. Then our final objective F statistic we can calculate. Then take F test statistic. F value. F value, when you calculate mean square regression divided by mean square residual, 810 divided by 97.5, that is F statistics. If you want this point also, you can calculate. 1200 divided by 5 means this point, but it is not required. Why? We need these two to calculate F statistics. Statistical packages also, when you see, you cannot see this point. No, we need this one. Right, now we write down. When we divide mean square regression, by mean square residual, when we divide mean square regression by mean square residual, F statistic can be calculated. Right. F mean square regression divided by mean square residual. Right, that is 810 divided by 97.5. What is the value? 810 divided by 97.5. 8.307. 8.307. 8.307. Right. Now you can find critical value now. Acceptance or rejection region in your third step. You draw a graph like this. That is your distribution, acceptance region, rejection region 0.05, 0.95, 0. Now this point you can decide. Degrees of freedom regression 1, degrees of freedom residual 4. From the table, regression 1 degrees of freedom, residual 4 degrees of freedom, identify this point as critical value. Right, what is my table? 1 degrees of freedom, 4 degrees of freedom, residual 7.709. 7.709. Was from this side, 4 and 1. Denominator means residual, numerator means regression, degrees of freedom. Okay? Any clarification? 7.709. Then 4 steps to finish. Then you take your step 5 conclusion. Last step conclusion. .307 where it belongs? It belongs to rejection region. H not rejected. H not rejected means H1 accepted. HA. It says that model is valid model. Then you can use that model, no problem. No any criticism, the panels no arguments because model is valid. Right. Then we write our interpretation. F test statistic is 8.307. 8.307. This belongs to rejection region. This belongs to rejection region. H naught is rejected. H naught is rejected. It indicates that model is valid. Model is valid. Different names may be model is valid, jointly significant, appropriate, those terms. Model is valid. Within bracket, jointly significant. Ekabaddhava vesasiveno. Jointly significant. Appropriate. Yogya. Appropriate. Model is jointly significant, otherwise appropriate. Valid. Right. Then my model y equals 34 plus 9x. Now I can present in a scatter plot. So that is a good model. Okay. Right. We can present this model. Right. Under that, write down. we can present the regression model. We can present the regression model in a scatter plot. Scatter diagram, scatter plot or scatter diagram. Vicinity pattern, scatter plot as follows. Right, now take the break. After the break, we can start scatter plot and other calculations. But it will take 10 minutes or 15 minutes, no? 15 minutes. Okay, take 15 minutes, then you can start. And in the attendance sheet, sign. Right. Let me construct scatter plot. X-axis, y-axis. X and y-axis. X values maximum 6. One, two, three, 4, 5, 6. Y-axis I take maximum 90, 20, 40, 60, 80, 100. You can decide the scale. If I didn't take plots, X and Y combination, we can present using dots, that is scatter plot. This is scatter plot. Scatter plot, otherwise scatter diagram. Which repeats that. Type 250. Data 2 and 50 means this point. This is the plot. 360. 360. You can take better than me because I don't use a ruler. 460. This plot. 480. Another plot. 590. Like this. 680. That is a scatter plot. Combination of X and Y is presented in a graph. That is a scatter plot. Right. I can present my linear line. My linear line y equals 34 plus 9x, my predicted value, predicted model. Take two coordinates, that is sufficient. Linear line x, y, two coordinates if you take is sufficient. X and y, two coordinates. I take x0 and x1, x0, x1, but otherwise I you can take whatever, x0, y4, no problem. That's the linear line. Right, when I take 0, y at value 34 plus 9x, 34 plus 9 into 0, 0 means 34. You know here 34. I take y because y means this is y hat. When y, what is y hat? 34 plus 9 into x value 1. Right, 34 plus 9 into 1, 9, 9 and 40, 9, 13, 1, 3, 43. 43. Two coordinates, cut down to the because you know 0, 34, one coordinate, 1, 43, another coordinate. You can present. 0, 34, 0 here, 30 means half of this gap, half of the upper part 35, approximately this point. Approximately take 34. x0, y 43. x1, 43. 1, 43. Half of this 50, 45, little bit closer. 43 means approximate this one. You can take better, right? 43, yes, right. Right, now construct linear line. That is my y hat plus 34 plus 9x. 34 plus 9x. Your graph is more accurate than me because I did not use the ruler. Right? You use a ruler. Use a ruler. Or your identity card. Linear line. Linear line. Right, this is the graph. This is the line of best fit. Sudusuma anusivume rekha. Line of best fit. Why this is line of best fit? Why this is line of best fit? You cannot find another linear line that is better than this. Meet what I am right? This is the line of best fit. You cannot find another one. Why? When you take this gap and from each plot to this gap, again here maybe the same. When you take the summation of this gap, to remove negative value we take square. When you take the summation of the square of that gap, minimum will be in this line. Minimum. වර්ග කරලා එකතු කරලා ගමන් ඔය gap එක අවම වෙන්නේ මේ රේඛාව. Right? You cannot find another linear line that is better than this. Never. That's why this is ordinary least square. Adutama varga krame, ordinary least square. You cannot find another linear line. If you want, you can check. You construct another linear line, check the gap. Again, linear line, construct many times. When you come to this line, that will be the minimum. Right? You cannot find another linear line. Right? When you practice in the future, if you can find any linear line that is better than this, right? Suppose that you practice by taking data, you construct this, then you find another linear line that is better than this. Please inform me also, right? Because that is a research. You want to publish in international reputed journal. So far, we cannot find another linear line better than this. That's why this is called line of best fit. Okay. Now, one linear line, another linear line minimum, another linear line minimum. Constructing linear lines many times, you construct, you calculate distance, scale. Minimum is what? That is the best line. ඒකත් ගන්න පුළුවන්. ඕම රේඛ ඇඳලා අඩු එක හොඳ ලයින් එක කියලා කියන්න පුළුවන්. ඒකට කාලය ගොඩක් යනවා. විභාගයේ තවත් ගැටලු තියෙනවනේ. මේක විතරක් නෙවෙයි. Therefore, ordinary least square you have to use. Okay? Right. Now under that write down. In the scatter plot, combination of x and y, combination of x and y is presented to represent all these plots, most appropriate linear line is the regression model. Therefore, it is called line of best fit. Line of best fit. සුදුසුම අනුසීහුමේ රේඛාව කියන්නේ ඒකයි. Line of best fit. When we take the square of the distance, when we take the square of the distance, minimum will be provided by this linear line. Therefore, this method is called ordinary least square. Method. Therefore, this is called ordinary least square method. Decrement nam ගොඩනැගිලි OLS කියලා ordinary least square method. Many times researchers use this one, and many times we apply every field. OLS regression model. Right. Then this model is appropriate. We identify. Then some calculations we do after that to decide the validity of your regression model for the coefficient of determination, adjusted coefficient of determination. multiple correlation, Durbin-Watson test statistics, heteroscedasticity test. These calculations we do to decide our model's validity further, right? Step by step we walk. Then you will become matured. You will be very powerful in analysis. Then we want to take further. Okay, those are provided in statistical packages as model summaries. आपकी सारांश के लिए model summaries. As the ANOVA result is significant, we can calculate. Otherwise, the model is not valid. Okay, right. Then we take coefficient of determination. Coefficient of determination. Coefficient of determination. Coefficient of determination. R square, R square, R square. As I mentioned, y bar, y hat, y. Right? Coefficient of determination means out of this total variance, how much is covered by the regression model, that is called coefficient of determination. Always this value will be between 0 and 1, 0% to 100%. Right? 0% to 100%. If your R squared value greater than or equal 0.6, we say 60% of the regression model or more covered, that model is called nicely fitted model. Nicely fitted model. Even though R squared is less than this, don't worry. This is significant, means this model is appropriate. You can use. But if the value is 60% or more, that model is called nicely fitted model. Nicely fitted model. Nicely fitted model. Right? That's a fitted model. Nicely fitted. Clear? Right. Now we write down like this. Coefficient of determination. Nirnana samgunake kya? Nirnana samgunake. Coefficient of determination. Out of the total variance, how much is explained? How much is explained? How much is explained by the regression model? By the regression model, that is called coefficient of determination. That is called coefficient of determination. This is denoted by R squared, R1 is denoted by R squared, R1 R squared. Always the value will be between 0 and 1. Always the value will be between 0 and 1. 0 and 1. Otherwise 0% to 100%. 0 and 1. If the value is more than, if the value is 60% or more, 60% or more, the value is 60% or more, within bracket r square greater than or equal 0.6. 60% or more, the model is nicely fitted. The model is nicely fitted. Nicely fitted. Even though r squared is less, even though r squared is less, we use the model, if ANOVA result is valid. If ANOVA result is valid. If ANOVA result is valid. But this is not valid. R squared is very high, but don't use that model. Important in this part, right? R squared. Right, then further R squared means out of our dependent variable, how much is covered by the regression model? That is R squared. Okay, R squared. Right, within that write down. Out of the dependent variable, how much is covered? By the regression model, that is called R squared. That is called R squared. Can parayat terjadi kocara kawan. That is called R squared. Dependent variable like kocara kawan. Right? How we can calculate? No problem. You can calculate. This is our covered amount. This is the total. And as a proportion or a fraction, you can write this, isn't it? You know what pain on it? R squared equals sum of the square equation divided by sum of the square total. SSR divided by SST. Right? Sigma y minus y bar, y hat minus y bar square explain various name. Y hat minus y bar. Y hat minus y bar explain divided by sigma y minus y bar square. Okay. SSRO SST. Attasiya dahaya divided by 1001. R square. 810 divided by 1200. 810 divided by 1200, 0.675. 0.675. 0.675. What can you say? Out of the total variance, 67.5% has been covered by the model. Nicely fitted model. Your dependent variable sales, out of the sales, 67.5% has been covered by the model. Right. Now we write down. According to R squared, 67.5% of sales income, 67.5% of sales income has been explained by the regression model. Model is nicely fitted. Model is nicely fitted. Model is nicely fitted. Right, then another value is there we want to calculate in regression model, that is called adjusted coefficient of determination. Adjusted coefficient of determination. Adjusted R square. Adjusted R square. Kalapu nirmana sambu. Tanggala punala. Adjusted coefficient of determination. Right, this is important in multiple regression model. So far we started simple model. अब मैं कहा simple model right? Simple regression model. Multiple regression model, more independent variables. When we have more independent variables in multiple regression model, this is important. Because in multiple regression model, when you include independent variable more and more, x1, x2, x3, x4 like that, R squared is going up. Even though unnecessary independent variables you include into the model, R squared is going down. Therefore, to adjust that problem, we calculate adjusted R squared. If you have huge gap between R squared and adjusted R squared, then that is a symptom there may be unnecessary independent variables in the model. Right? For that purpose, we calculate adjusted R squared. In simple regression model, this is not required. Right? But we can calculate always adjusted R squared is less than R squared. Huge gap means unnecessary independent variables you have used in the model. Then in research we can decide whether you have used relevant variables. Sales income, promotion expenditure, price of others, other price, right? Advertisement, campaign, yes, it's good, right? You use another variable, that is the number of accidents in Canada, sales income. So then unnecessary independent variables in the model, right? Then no effect, isn't it? So then huge gap may be between adjusted R squared and R squared. R squared එක adjusted R squared එක අතර ලොකු gap එකක් තිබ්බොත් අනවශ්‍ය විචල්‍ය අරන් නැති model එකට. ඒක තීරණය කරන්නයි calculate කරන්නේ. Right? In multiple regression model it is simple. A simple model එක independent නේ. හරි නේද? හරිද කියන්නේ මම හැම වෙලේම කියනවා හරි ඒවා කියන්නේ. හරි. අනේ තේරුණාද කියලා. Okay? Right. Because some advanced calculations I am going there step by step. Okay? Right. Now we write down adjusted coefficient of determination. Right. This is important in multiple regression models. Multiple regression models. This is important in multiple regression models. If there are unnecessary independent variables, in the regression model, R squared will go up. R squared will go up. R squared will go up. To adjust this problem, adjusted R squared is calculated. Adjusted R squared is calculated. Adjusted R squared is denoted by adjusted R squared is denoted by R by squared. R by squared. R by squared. Always R by squared is less than R squared. Less than R squared. If there is a huge gap, there may be unnecessary independent variables. In the regression model. Unnecessary independent variables in the regression model. Demand you forecast, you use price, good. Additional expenditure, okay. Then income of people, they are representing variables. Right. As I mentioned, number of accidents in front of SAB, you include to demand forecast. Unnecessary independent variable. Then R squared is going up. That problem can be adjusted by R by squared. Okay. No hard and fast rule to determine between that, but 30%, 40%, 30% or more, you can decide unnecessary independent variables. Right. Always R by squared is less than that. R squared. How we calculate this? Calculation is not difficult. R by squared, then you calculate 1 minus R squared, n minus 1 over n minus k minus 1. Degrees of freedom, total degrees of freedom less than 1. This is the formula. Right. Formula is given below. R by squared equals 1 minus, within bracket 1 minus R squared, n minus 1 over n minus k minus 1. Okay, then calculate 1 minus R squared, 0.675. N 6 minus 1 total n 6 minus 1 independent variable minus 1 means the 0. Right, then simplify. 1 minus 5, 10, 7, 8, 2, 1 left, 6, 7, 3. 6 minus 1, 5, then 4. But 1 minus 1, 6, 7, 5, 9 minus 0.593 approximately. Right, then 59.3% is covered. 67.5%, but here 59.3%. Not a huge gap. Then you can say here, according to R by squared, 59.3% of sales income of sales income has been explained by the regression model. Has been explained by the regression model. Has been explained by the regression model. Dan kaitan ini siapa pada terlalu tiap kita rawat ini. Ini kau rasa. But here that is not a big problem. 59.3% of sales has been covered by the model. Right, then next one is multiple correlation. Next are very multiple correlation. Multiple correlation. This is also important in multiple regression model. If you have more independent variables, how all these independent variables are jointly correlated with your dependent variable. But correlation analysis we calculate pairwise x, y. If you have more variable x1, y, x2, y, x3, y, how they are correlated. But all the independent variables, if you want to correlate jointly, you use multiple correlation. In simple regression model, we have only one independent variable, therefore coefficient of correlation will be multiple correlation as well. Simple regression model like multiple correlation like a simple correlation like that. Simple means Carl Pearson coefficient of correlation, you remember the same. Right, this is also important in multiple regression model. Multiple regression model. Now we write. This is also important. This is also important in multiple regression model. In multiple regression model. In multiple regression model. If there are more independent variables, we can determine how they are jointly correlated. How they are jointly correlated. With the dependent variable. With the dependent variable. Multiple correlation is denoted by capital R. Capital R. Multiple correlation R. In simple regression model, this is similar to coefficient of correlation. This is similar to coefficient of correlation. So capital R equals simple R. This is multiple correlation. Multiple correlation. This is Pearson correlation. Pearson's correlation. They are equal in simple model because we have only one independent variable. How you can calculate this? R. Coefficient of determination you have calculated R square. Take the square root of that. That is R. It means that 810 divided by 1200 is square root of that. What is R square? 0.810 divided by 1200. 1200. 0.675. Square root of that. Square root of that. Square root of that 0.821. Right, check Karl Pearson correlation. This should be same thing. Pearson correlation last week we calculated. Is it same? 0.821. Karl Pearson. Right, that's right. For simple model, coefficient of correlation will be multiple correlation as well. But multiple regression model, it is different. Only one independent variable, this relation. But more independent variable we are having x1, x2, all these together, how they jointly correlated with this. That is indicated by multiple correlation. And make it yours, make coefficient of correlation with it. Right, same thing, 0.821. Right, another calculation we want to do, that is Durbin-Watson test. Durbin-Watson test. DW test. DW test. Right, Durbin-Watson test. You know you are having residuals. Residuals. Okay. Residuals. Residuals. That is called errors. Those. Otherwise we call disturbance. Disturbance. So disturbance. We want to decide whether our residuals are independent in the model. Because if the residuals are correlated with them, the residual correlated, that is a problem. Because in the regression model, variables are not correlated, residuals are correlated. Residuals means unexplained variance. Unexplained variance correlated, that is a big problem in the model. For that purpose, we use Durbin-Watson test to determine whether residuals are independent or not, whether they are correlated. Residual correlated, those are correlated. That is a problem, isn't it? That is a problem. Okay. What do you think? Do you think what happened to us? Okay, I cannot understand whether you understood or not. Yes, I know that whether you understood or not, this is your normal appearance. But residuals should not be correlated. They should be independent. You are independent. Swadhina. In time series data, we say autocorrelation. Autocorrelation means residuals are correlated. That's a problem. Big problem. Residuals should not be correlated. Now we write down. If residuals, within bracket write down these terms also. Errors, disturbance. Errors or disturbance. If residuals are correlated, they are not independent. They are not independent. They are not independent. If residuals are not correlated, they are independent. They are independent. If the residuals are independent, that regression model is more valid. To determine whether the residuals are independent or not. We apply Durbin-Watson test. Durbin-Watson test. Durbin-Watson test. Durbin-Watson test. WATS, sorry. Durbin-Watson test. Always DW test value will be between 0 and 4. Will be between 0 and 4. If the value is close to 1, if the value is close to 2, residuals are independent. As the range we take 1.5 to 2.5. 1.5 to 2.5 as independent. Residuals 1.5 to 2.5 on DW test, okay. Like this. DW test when you take 0 to 4. Right? Close to 2 means this range 1.5 to 2.5 you can take independent. Right? Beyond that, this range and this range not independent. Here positively correlated residuals. Here negatively correlated. But no need to worry about positive, negative. Here not independent. Here also not independent. One 1.5 to 2.5 you can use as independent. One 1.5 to 2.5 independent. Beyond that, not independent. 2.5 to 4 not independent. 0 to 1.5 not independent. 1.5 or 2.5 independent. Between that range. How we can calculate this? DW test. Using residuals you do. Durbin-Watson test we calculate residual, one observation residual minus previous residual. I minus 1 is previous residual. And take square root of that sigma 4.
divided by residuals of I period square sigma. This is your DW test. Sigma Ri minus Ri minus 1 square over sigma Ri square. R kilogram residuals. Ri means ith residual. Ri minus 1 means previous residual. Previous residual. I minus 1 previous residual. T today residual. T minus 1 yesterday residual. Okay. T time period current year. T minus 1 previous year. Ith observation. I minus 1 previous observation. Lazy neither. Very easy. Okay, practice. Then it is easy. Right? It will be difficult. It is not easy if you become lazy. Right, now let's calculate residual. Residual we have done. What is residual? Y minus Y hat residual, isn't it? Okay, here is. I want to calculate residual. Right, R we take residual of I. Residual of I means Y hat, Y minus Y hat. Residual. Actual value के predicted value का आउटपुट residual में. मम्मी किए ना को देते ताका था ना बोला. Actual value Y model Y hat Y bar Y. Residual Y minus Y hat. Residual. Okay. Clear? Right. Then calculate Y 50. Y at 52. Residual minus 2. Y 60. Y at 61 minus 1. Okay, square का मेन कर. 60 minus 70 minus 10. 80 minus 70 plus 10. 90 minus 79 11. 80 minus 88 minus 8. Is it over? R. Alright. In the formula, dW we calculate residual I minus 1 squared sigma residual I squared. Right? Alright. Okay, clear. Now let's take Ri minus 1. Ri minus 1. What is that? Previous residual. Kalim residual. First observation to what is the previous? No. Second data points minus 1. Previous residual minus 2. Make the numerator. This one previous minus 1. This is 10 previous minus 10. 11 plus 10. Minus 8 plus 11. Previous set I minus 1. Clear? Right. So t කියලා කිව්වොත් හිතන්නකො අද t minus 1 කියන්නේ ඒක ගන්න. Right, then applying the formula. Right, now I calculate this Ri minus 1 square. First data points you do not have. Ri minus 1 is not there, therefore don't take it. Others calculate. Minus 1 subtract minus 2 square. Right. Minus minus plus 2, then plus 1 is square. 1. Minus 1, minus minus plus 2, minus 1 plus 1 is square plus 1. Right. Then minus 10 subtract minus 1 plus 1 minus 10 minus 9 minus 9 is square 81. 10 subtract minus 10 square plus 10 plus 20 square 10 minus 10 then 400. Subtract 11. 11 subtract 10 square. 1 square 1. Minus 8 subtract 11 square. Here 8 to 19, here plus. Minus 8 subtract plus 11. Minus 11. Then minus 19 is squared. That's 250, 19, it is squared. 19 is squared. 361. 361. Now take the summation, that is sigma residual I minus residual I minus 1 square. How much? 82 plus 401 plus 361. 844. 844. This part okay. 844. Now take this part. Sigma Ri squared. Ri squared. It is okay. This part also you can calculate. Minus 2 squared 4. 1 squared 1. 10 squared 100. 10 squared 100. 121. 64. Previously also you calculated this. In ANOVA table you can see this value. Sigma Ri square. Sigma table ANOVA table එකේ තියෙනවා.